All right, so let's do some more 8.3 my calc babies. So trigonometric integrals. Now let's take a look at some scenarios where we're dealing with tangents and secants, right? And so in this case, we have tangents that are with powers that are odd and positive. And here, let's jump right to the tips. So the tips for this is going to be, well, we're going to end up letting u equal a secant. But here's the important part. We're going to have to save a secant x tangent of x, just like before. And that makes perfect sense, because if you allow u to equal secant x, then du is going to be secant x tangent of x dx. Right, so this is what we mean. This is what you're going to have if you ever want to substitute du under these conditions, then you're going to have to leave yourself a secant x tangent of x for later. All right, now, so let's go ahead and rewrite this. So as of right now, I'm gonna go ahead and write example 4. I think you'll understand this. The square root of secant would be secant to the power of 1/2, but I'm going to bring it up to the numerator, and so that's secant of x to the power of negative 1/2, and I still have my tangent cubed of x dx. All right, here's the part. So as of right now, if I'm going to follow these little tips, then I need to factor out a secant tangent, right? It's the only way I can secure that I'll have one for later. So let me go ahead and do this. Right, I'm going to go ahead and show you, if you, from right here, from this step right here, if you go ahead and factor out a secant x tangent of x, this is what you would have. So you would now have secant x to the power of negative 3/2 times tangent squared x, and here is this factor, secant tangent. And now I ask you, do you know, or can you produce what I have just underlined? Can you do that? Can you actually factor a secant x tangent of x out of this step right here? Well, you should pause the video. You should try that. I'm going to, down at the bottom, I'm going to erase this after I do it. It's just, remember something. To factor out means to divide out. Right? So I hope that makes sense. So really what you're doing, so let me rewrite what we had. We had secant x to the negative 1/2 tangent x. And if you have decided that you want to factor out a secant tangent, to factor out is to divide out. So you're really just dividing by whatever it is that you were trying to factor out. That's it, right? So that's how we end up with secant of x to the negative 1/2. Well, look, what do you do when you divide like bases? You subtract 1. You subtract them, right? So that's minus 1. And then it's tangent of x, and then it's going to be 3 minus 1. That's how we get to what we have here, right? Negative 1/2 minus 1 is negative 3/2. 3 minus 1 is 2. So I'm going to leave that there for just a second. If you're kind of copying notes, I'll kind of park that right there. And now let me jump back up to where I was here. So at this stage, you have secured a secant, like this step right here. Save a factor of secant x tangent of x for du. So you've done your job. The tip that I think I'm missing here is after you do that, after you've secured that factor, what we're going to end up doing is turning everything else into secant. Okay, so at this stage, what I want to do at this stage is I want to turn all else to secant. All right, so all that requires is that this tangent squared has got to go, right? And I'm just going to simply use, again, it's just these Pythagorean identities, tangent squared. That's just, what is that? That's just secant squared minus 1. All right, so at this stage, I'm going to erase the bottom in just a second, but at this stage, I'm going to rewrite everything, but I'm plugging in the secant squared x minus 1 in here for tangent. So that leaves me with secant to the negative 3/2 times secant squared x minus 1. Okay, so life is good, and I still have my secant x tangent of x left over. And what do you propose from here? What do you think is going to happen from here? Well, the whole point of this was to use u substitution. So let's use u substitution. Let's substitute. You can distribute that if you want to, if that helps you. As of right now, you can distribute your secants, and then you can u substitute, or you can u substitute and then distribute. Either one, it doesn't matter. However you do it, I'm trying to expedite the process a little bit. We're going to end up with, I'll go ahead and distribute for you. I'll just assume you took that approach. So this would end up, so secant to the negative 3/2 times secant squared would be secant to the half. Right? And then obviously that would be minus secant. So now we're multiplying by 1. So now this would be secant negative 3/2 x. And of course, you still have your secant x tangent of x. All right, so time to u substitute. So this ends up being u to the 1/2 minus u to the negative 3/2 and this right here becomes du. All right, I'm going to just produce the answer at this stage. You can do the rest of this. So the solution in this case, after you integrate and back substitute for u, is 2/3 secant to the 3/2 plus 2 secant to the negative 1/2 plus c. All right. I'm going to leave that there. What I'm going to do is I'm I don't want to continue this game because you got the theory. This is just a different approach now. You have secant as powers even and positive. So in this case, you would want to save a secant squared and convert the rest to tangent. Now, what I'm going to do for this problem, this is all that I'm going to do for this problem, is you would have, in this particular example, you would let u be tan 3x, and then du would be 3, of course, if you secant squared 3x dx. That makes sense because you would need chain rule to take that derivative. And at this stage, you should go through this on your own time and see if you can produce the following answer, which is just tan to the 4th 3x over 12 plus tan to the 6th. I keep forgetting my x's. My apologies. Actually, no, I didn't forget my x's. I'm losing my mind here. So it's tan to the 6th 3x over 18 plus c. You should try to see if you can produce that on your own time. The last problem of this section is what happens, right? What happens if you end up with different angles, right? I have an angle of 5x inside of sine, whereas I have an angle of 4x inside of cosine. Well, there was some, if again we're kind of going back to trig class, there were some identities where we can turn products to sums and sums to products. And one of the things that you can do now, I've produced, what I've produced off to the right is out of your textbook. So this is the way that they write their product to sum formulas, various product to sum formulas. So in this case, they use, instead of using, say, alpha and beta, they use m and n. So in this case, you would use the following formula. M is 5x, n is 4x. I don't like that. I'm going to go here. I'm going to use, I'm just rewriting the formula in terms of alpha and beta, right? This mirrors if you had me for pre-calculus. If you didn't have me for pre-calculus, then shame on you. Shame on you. It was like studying pre-calculus with Michael Jordan of pre-calculus, I guess, is the only way I could explain it to you. You missed it. Ready? So this is just going to be a matter of plugging in for alpha, plugging in for beta. So I'm going to go ahead and do that right now. So this would just be sine of 5x minus 4x plus sine of 5x plus 4x. Right? So using that product to sum formulas, we end up with sine of x plus sine of 9x. Now, why do we care to do such a thing? Well, if remember, sometimes we like to break up an integral into multiple parts and then just take the integral of those parts. We could not do that the way that example set. Okay, but as soon as we were to just use that product to sum formula, look, we can do this now that, well, I'll bring that half out front. Now we can just think about that as integrating sine of x with respect to x plus integrating sine of 9x with respect to x. And that is easy. I'm just going to jump to the answer because that is easy integration to do. And just a little bit of u substitution should get you to 1/2 half, that's actually going to be negative 1/2 of cosine of x minus, you got to bring that 9 out, so that's 1/18 cosine of 9x plus c, all done. All right, so we're done with the section. You could either be thinking, thank God I have a formula sheet when I take these tests. You also might be thinking, why didn't I pay attention in trigonometry class a little bit more? And both of those are legitimate concerns or thoughts. Just practice. That's all. The only way you get better at math is to sit down and do some math. See you soon.